Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So we'll continue our discussion regarding probability. We still discuss about base 8.1. So now in this video we discuss about union and intersection between two events, and also we discuss how we encounter or how we solve an mutually exclusive event. So this is the outcome for this video. So intersection and union between two events. Right, so first of all, we take a look what is a composite event. So basically, composite event is we will define a new event based on combination of A and B. Okay. So there are two possibilities. That is the first one we and between two events, and also the other one is or between two events. So as you know, the notation and will be intersect and or usually will be union. Okay, so these are two examples of the composite events. And then for intersection, so intersection, this is the same notation of intersection, that is and. So between two events, it is and, it is intersection, right? So means that both A and B happens. You can list out, okay, either set form, the list of in event A and list on event B. So if we have both cases in A and B, so this is what we call intersection. Okay, so if we sketch a Venn diagram, so remember Venn diagram. So the first circle is event A, the second circle is event B. If the two circles are overlap each other, so this overlap region, this is what we call intersection. So the formula to find intersection is we combine together event A plus event B and then the union between these two. So we will got the intersection. Okay, next about the union. So union is or event A or event B. So either event A or B happens. Okay. So this is the whole thing. Okay, not the only the intersection, the whole thing here. So this is A union B. So A union B, A, B, and in between we also have intersection. So to get the union, actually we will count this one 2 times. Okay, if you notice, A only, B only, and this one already 2 times. So we remove one of this one, so this one we have a minus intersection in the behind here. So A, B, so okay, notice we have 2 times, so we have to remove one of 2 times, so that's why we remove, we have a minus A intersect B. Right, so now we take example 3. So a die, remember we already discussed what is a die. This the single dice, and a coin are tossed together. Find the probability that we get a head, a number greater than 2, a head and a number greater than 2. Okay, so notice, especially for question C and D, in question C we have and question D we have or. So before that, we try to solve A and B first. So these two is basic event here. So if possible, we can sketch. Okay, so this is how we sketch. So this x-axis here represent the outcome from the die, that is all dice 1 until 6, and the y-axis here the represent the outcome from the coin, that is head or tail. Okay, HT represent head or tail, and here number 1 to number 6 from the die. Okay, so the total outcome from these two events is 12. Okay, 6 times 2, which is 12. So this we have 12 outcomes. So NS, the total outcome, NS 12, and then we know event A to get a head. So head here we have 6, right? So NA is 12, NA is 6, and event get number greater than 2. So remember, greater than 2 means that more than 2. Okay, no, 2 is not included. So we start from 3. So this is for event B. Okay, so we already shaded using the square here, the yellow one for event A and the purple one here for event B. and in between you notice the intersection between these two events. So in the previous slide we noticed that and B also 8, okay, and for event A, so we know it is 6, so 6 over 12, so we got 1 over 2. And then for event B, the center is, you don't want to write the center, is okay. We already accept this answer, okay, so no need to write down this statement. Right, next for event B, so we know event B is 8, so 8 over 12. So the probability is 2 over 3, so no need to write down the statement here. So enough with the calculation. Right, next for event question C, there is a head end, okay, which is the intersection. So the intersection, we notice that the intersect is 4, right? Head and also greater than 2. So we have 4 outcome. So 4 over 12 is basically 1 over 3, right? And then again, we don't need to write down this statement here. So just A intersect B, 1 over 3 is enough, okay? And then next for question D, a head or a number greater than 2. So we have to use the union formula. So remember union A plus B minus intersection. So from the previous calculation, straight away 10. So if possible, you can write down also. Remember, firstly we have 6, and then we have 8, right? And then minus 4. So using this formula also, we can get 10 over 12, okay? So 14 minus 4 is 10 also, 10 over 12. So I think better to use this formula, okay? If you don't sketch. If you sketch the outcome, x and y axis, then we can straight away count it as a 10. Okay, this is what I said. We use this formula. So 1 over 2 plus 2 over 3 minus 1 over 3. So originally this is this thing, okay? 6 plus 8 minus 4 over 12. So then we got 5 over 6, okay? So that's the solution for question D. And again, no need to write down the conclusion below here. Okay, next for example 4. The two event A and B are such that event A is 17 over 25. So probability of event B 1 over 5, and probability of A union B is 3 over 5. So find the intersection. Right, so this is basically just straight away substitute into the formula, right? So we know A plus B minus union, right? Okay, so A plus B minus union. So just substitute all this value and just press your calculator and you got the answer, that is 7 over 25. Okay, this is very easy, very straightforward. Okay, next. So after we discuss about union and intersection, so we'll take a clue. What is a mutually exclusive event? So mutually exclusive event is actually the two events cannot happen together. Okay. So it can be either one but not both. So that's the meaning of mutually exclusive event. Okay, for example, these two events. So as you can see in the Venn diagram here, we don't have any intersection or overlap between these two circles. So this is the cases of mutually exclusive event. So in other words, A union B is empty set. Okay, the notation here refers to empty set, or we can also write down like this to represent the empty set. So in other words, in these cases, since we don't have intersection, so the union only we add the two events. So probability of event A plus probability of event B without the intersection, because intersection is already 0. Okay. So what is an example of cases of mutually exclusive? So let's say in the tennis competition, Johari and Meng Kiong are fighting for the championship. So let's say Johari and Meng Kiong both progress into the final match to determine which one will become the champion. So let's say the event J, Johari wins, and event M, Meng Kiong wins. So obviously we cannot, it cannot happen two persons win at the same time, right? So this is what we call the mutually exclusive event. Okay, means that only one of them can be champion. It cannot both of them will be champion at the same time. Right. So now in example 5, the following table gives a two-way classification based on gender and employment status of a group of youth in the city. So as you can see in the column here, we have employed and unemployed. In the row here, we have male and female. So later on, we will encounter more table like this one, okay, in the following video. So if a youth is selected at random from a group of youth, find the probability that the youth is unemployed, employed, a female. Right. So this is the table I bring here. So I can show how we get 600 here. So firstly, we sum together between employed. So here we have 490. And then for unemployed, we sum together, we got 110. So the total here would be 600. And then here we can also sum between for male employed and employed. So we got 320. So same also for female, we can sum between employed and unemployed. So we got 280. So again, we can check in the sum these two between male and female. Also, we can get the total of NS is 600. Right. So this is how we got 600 for NS. And then employed 490. Okay, we already show in the table. Employed 480, unemployed. So unemployed is 110. So 110, so divide by 600. Then we got 11 over 60. Okay, next for employed. So for employed, we already calculate that is 490. So 490 divided by 600. So we got 49 over 60. Then lastly for female. So we already total up for female. That is 280 here. Okay. So 280 divided by 600. Then we can get, press your calculator. We can simplify to be 7 over 15. Okay. So that's the probability for this question. Right, so next in example 6, so we have two events, and given the probability of event A is 1 over 2, given also the probability of event B is 7 over 12, and probability of complement of union AB is 1 over 4. So the question here, are A and B mutually exclusive? So what's an idea to solve this question? We have prime here. So what's the idea? Right. Actually, there are two methods to solve this question. So let's take a look about the first method. First, as I said earlier, since we know the complement of union AB is 1 over 4, so if we can subtract from 1, then we can get the value of probability union of AB, which is 3 over 4. And then using the addition, that is the formula that we discussed earlier regarding union and intersection. So we know that the formula for the union is probability of A plus probability of B minus intersection of AB. Okay, so if we can show that this intersection has a value and not 0, then we can conclude that it is not mutually exclusive. So right now we substitute the value. We know this is 3/4 as we showed earlier, and then from the question we can also substitute the value of probability event A and probability of event B, which is 1/2 and 7/12 respectively. Then when we calculate the probability of intersection of AB, then we can get the value is 1/3. And as I said earlier, so we already showed that 1/3 is not equals to 0. So we can conclude that therefore A and B are not mutually exclusive. Okay, so this is one of the method that we can use in order to show that it's not mutually exclusive. So now we'll take a look about the second method. So what's your opinion on the second method? What formula that we use? Okay, in the second method, again same, we find out the union first, which is 3/4, and then we directly using the formula of mutually exclusive. Okay, so using the formula of mutually exclusive, we know we don't have intersection, right? So if we sum between these two probability A and B, we find out that the probability is 13/12, which already exceed by that is more than 1. So obviously this is far from union of AB. So we can conclude below here, since union of AB is not equals to probability of A plus probability of B, therefore we can prove that A and B are not mutually exclusive. So this is the two methods that we can use. Which method that you prefer to use? If you forgot to use this formula, I suggest you to use the first method, which is much safer. Okay. Right. So I think that's all for this video regarding union and intersection, and also about mutually exclusive event. So don't forget, in the next video we'll discuss about conditional probability. So until then, thank you very much. Bye bye.